All right, we're live. All right, so what we want to talk about here is why it's so important to get what geologists call a fresh face. So Neil, if you want to point to this rock, notice how, as we look closely, it's covered in lichen. Lichen's biology. We don't, as geologists, biology often gets in the way. So obviously this rock is not lichen. You know, we don't care about that. But even if we look at something a little less obvious, here, Neil, let's go over to this. You know, there's bare rock right there, but you still can't tell much about it. It doesn't reveal what the rock actually looks like. In contrast, let's see if I can find a shard on the ground. That's a decent one to start with. Oh, here we go. So here's a rock where we can see more of what the rock actually looks like. This has been a rock that was busted in half or something previously. So that's the outside of it, covered in lichen and weird things like that. And there's the inside, which is much more interesting for us. So what we're gonna learn now is how to safely collect a fresh face. So Neil, what you wanna do is look for kind of an edge that your hammer can easily bust off. We're gonna make sure everybody's got safety goggles on, and then you're gonna smash off a fresh face. So find something that looks good to you, and we'll break it.
I can't see very well without my normal glasses.
Oh, I'm sorry.
Yeah, this is great. Okay.
Sure. And usually I would, well, actually, so you've got a chisel end and a blunt end. The blunt end, actually either could work. I usually use the blunt end. I use the chisel end for digging, but go for it. Woo! That just went flying. So one, notice how everything went flying, but two, now all of a sudden we can see way more detail. You can see there's little bubbles, so those are our vesicles, and the color is different. The other thing to notice here is you can see what we call an oxidation rind or a weathering rind. It's almost like there's a layer on the outside of the rock. So that's pretty cool. That tells us that the outside of the rock is not representative of the inside of the rock. The outside showing the thousands or millions of years of weathering. Cool. So at this point, let's find a couple good fresh faces. There should be just, yeah, take a minute, look around, see if you can either knock a good one or find a fresh shard.
Okay.
From a previous time that we've done this in this area. And we'll reconvene and take a look at them. So folks, as we're scanning around, I should tell you I've been out here with previous, there we go, that's better. And we've broken a lot of rocks out here, so we have every reason to believe that there's already some good fresh faces out here. Ooh, I wonder if we do this in the light, we'll probably get a better sense of what's going on with these lovely rocks. Here we go. Alrighty folks, so this is a really nice example. So hopefully you guys can see better because we're in the light now, but this is a large chunk of rock that has been previously broken. Contrast it with this, covered in lichen, old. Here you can actually start to see all those little white needle-like shapes. Rectangular shapes. You know, if we had a hand lens, we would be looking really closely at it. Oh, Neil, do you have your hand lens on?
Yeah, let me grab it.
Cool. Neil's gonna grab a hand lens. But this is a good example of a fresh face versus a weathered face. Other examples, there again is our weathered face covered in lichen. I spin this rock over. That's where it was recently broken. Look, you can see it's shiny. That's a huge clue. I don't know if you guys are getting the same reflection that I am, but there's little crystals here that are lighting up as I rotate this. And each one of those is an individual mineral, probably a feldspar if we're seeing a white rectangular shape. So Neil's got his hand lens. Another skill that we would be learning if this was real geology and not virtual is how to use a hand lens. Neil, do you happen to remember how to use a hand lens?
No.
All right. So the thing everybody does wrong with the hand lens is they take the hand lens and hold it to the rock. That's wrong. The thing that you do that's right, which is more challenging if you're wearing glasses, I'll show you if I wasn't wearing a glass. I would take the hand lens and put it right up to my eye. I'm not gonna do that with Neil's because of this whole coronavirus thing. But I would put it right up to my eye and then bring the rock up to it. That's got to look weird. So what Neil is doing right now is much better technique. Neil, do you want to, tell us what you see when you get a good close-up of that.
Yeah, so some of those features that Hal was talking about, I'm able to see kind of the boundary of lots of what look like different minerals within this sample.
And what do you see that makes you think it's a mineral?
A consistent color, and this is a non-weathered face, but just seeing like a consistent brown, shiny color in kind of smaller pieces distributed throughout the sample.
Awesome. So that's super cool that you said a brown color. So I'm gonna refocus on this one because this has some obvious minerals. So when we talk about minerals in volcanic rocks, we'll often call them crystals, and they're basically a function of cooling time. The bigger they are, the slower the rock cooled. So many volcanic rocks don't have any crystals because they cooled super quickly. Others have some. And in basalt, we expect to find two different types of minerals, if you remember from our lecture. We expect to find green olivine and white rectangular feldspar. There's our white rectangular feldspar. Neil found something that was brown. So it turns out olivine weathers to a brown color when it's exposed at Earth's surface for millions of years. We're currently on Aubrey Butte with lava that's over 4 million years old, hence all the olivine is gonna have weathered to that brown color. Cool, so we've found the two major minerals. What else do we want to talk about here in terms of describing this rock? Tell you what, so folks, at this point, you want to talk about, basically in your description, what have you seen from these close-ups? Oops, sorry. Something like that. Neil, you want to pass me the one that you were looking at?
This one.
And folks, if you ever need more time to look at something, just pause the video. So here's a great one. And what I'm going to do to help you guys with this is I'm rotating the rock ever so slightly. What that does is it changes the angle that the sun is bouncing off of it, and that it reveals the minerals. Every time you see something light up, that is one individual crystal. I think that's probably the brown one that Neil was talking about, or maybe that right there. So this is a great example of what we're talking about. I'm just gonna kind of move this around, and whenever it's working for you, pause it and describe what you're seeing there. So to reiterate, that's our weathered face, that's our fresh face. This is kind of a weathered part within it. You can see how it's a little discolored. And as far as the sketch goes, let's do an up-close sketch of the rock itself. So things you want to focus on are the shapes of the minerals, if you can see that at all. Do you see holes in the rock? If you're not using colored pencils, that's fine, but maybe label the colors. So like maybe you can just see there at the tip of my fingertip, there's a little brown smudge. That's a chunk of that olivine. There's a chunk of the feldspar, it's a little whiter. Yeah. So let's say if you haven't finished, pause it, finish on your own, and now we're gonna get to the last part of stop one. So Neil, I've got a question for you.
Yeah.
Did you find holes in these rocks, like vesicles, gas bubbles?
No, not on these rocks.
Okay, so tell you what, let's take a minute and look closely and see if we can find any. So I noticed there's one. There's another, there's another.
This one, I mean, this is already chipped off, but that's got some bigger ones.
Yeah, so two things to note. One, Neil's saying, hey, there's a lot more big ones right here. Awesome, so that's more vesicular basalt. And two, he's like, this rock's not part of the rest of it. So as geologists, when we're making interpretations and observations, we gotta be careful. Are we looking at a rock that is part of the outcrop? In that case, we call it in situ. So like this boulder right there is part of the outcrop. It's in situ. As opposed to just a chunk on top that maybe somebody picked up and put here. So good learning point there. Right now we're going to continue our search for vesicles, bubbles in the rock. Oh look, here's an area with a whole bunch of them. like tons and tons of tiny little ones down there. And if I look over here, I don't know how good resolution you guys are getting, but I'm getting lots of, there's a bunch of bubbles right there, a bunch right there, a bunch right there. But then other places, we didn't see any at all. Like those first rocks me and Neil looked at. So my question for you guys, so this is your last question for stop 1. Why is it that the vesicles vary? Why isn't all of the rock here super bubbly? Or why isn't all of the rock not bubbly at all? I'm actually not going to give you the answer right now. I want you guys just to think about that and come up with your own thinking. Yeah, Neil, anything you want to add?
I don't think so.
All right, so that's stop 1. I'm going to stop it now, and next video will be stop 2.